Good afternoon, everyone. My name is Kelly Childress, and I'm the Director of Education here at Stratford Hall. I just welcome you here to site for one of our, I would say, first paleo lectures since the pandemic. So we're really glad to have everybody back and hope to start having more of these here on site as well as part of our paleontology program here at Stratford Hall. Today I am joined by Dr. Robert Weems and Bryan Landacre, who will be our presenters today. And they will be talking about the Pleistocene era or epoch here at Stratford Hall. So to tell you a little bit about our speakers, Dr. Robert Weems grew up in Ashland, Virginia, so he is we'll call him a local. And in the second grade, he read a book about dinosaurs. And then from then on, he became determined to learn everything he could about the fossil animals in Virginia and nearby regions. One of his favorite childhood haunts was the cliffs at Stratford Hall and Westmoreland State Park, and he spent many years there collecting fossils and studying the geology of this area. He received a bachelor's degree in biology from Randolph-Macon College in 1968, a master's degree in geology from Virginia Tech in 1972, and a doctoral degree in geology and paleontology from George Washington University in 1978. Dr. Weems worked for the U.S. Geological Survey in Reston, Virginia from 1978 until 2010, studying and mapping the stratigraphy of the Piedmont and coastal plains tract in the southeastern United States. Since then, he has spent much of his retirement time continuing to do research on fossil animals and the geology in and around Virginia. So we are very thankful to have both Bryan and Dr. Weems here with us today. Please give them a big round of applause as we start our presentation.
Here are title days, the Early Pleistocene fossil fauna and Flora at Stratford Hall, Steadily expanding story. My name is Bryan Landacre. I'm a paleontologist at the U.S. Geological Survey. Paleontology is the study of fauna. And that's what I've been doing for the last 20 years or so. This has got me interested in fossils, and together we're working on the Pleistocene at Stratford Hall. I'm going to have three parts. The first part, just do a basic talk about the geology of Stratford Hall, then get into the Pleistocene Ice Age, and then talk about the Bacon's Castle Formation. Part two, I'll explain a little more of what I do, how paleontology works. And part three, okay. Stratford Hall is located along the Potomac River estuary in northern neck, Virginia. I'm not from around here, so when I first started studying the geography of Virginia, I thought it was pretty interesting. This is called Northern Neck. So I assumed this was called the Middle Neck and this was the Southern Neck. But if you look on maps, this is actually the Middle Peninsula and then the Virginia Peninsula. But Dr. Lee has told me in the old days, they used to actually call it the Middle Neck and the Southern Neck, correct? So I'm not sure when that changed, but I like Northern Neck. Deep below Stratford Hall, the geology stretches back 330 million years, while the cliffs represent the last 15 million years. But there's a lot of missing time. This is a typical scarp of the beach here at Westmoreland, or Stratford Hall, excuse me. Takeaway here is that there's a lot more missing time than there is present time. So this represents the last approximately 15 million years. This Calvert Formation is like close to the beach level. That's about 13 million years. Above that is the St. Mary's Formation. But you see all these gray areas are missing time. He's been removed away. What more missing time in the cliffs? There is present time. The Pleistocene Ice Age ranged from 2.588 million years ago to the Holocene, approximately 11,700 years ago. The Chesapeake Bay was just beginning to form at the end of the Pliocene and beginning of the Pleistocene, and it wasn't fully formed until the Holocene. The Pleistocene was an epoch of dramatic climate change, often referred to as the last great ice age. But it was more than just a single ice age. It was a succession of glacial and interglacial cycles, and these are driven by Landacre cycles. So there are three takeaways here with these cycles. So the first one is precession. And you've all seen a top spinning on a table, and you have that wobble. That's basically, in a simple form, that's what precession is, precession of the equinoxes. And that cycle can range from 19,000 to 24,000 years. Number two is the eccentricity. That is when the Earth travels around the sun. These cycles at 100,000 to 400,000 years. And you need to be more circular or more oblique passage around the sun. And then the third one is the tilt. You take that top spinning on the table, and then take that table and tilt it. That's an additional adjustment. And all these affect the heat budget for normal latitudes. From 3 to 1 million years ago, the climate cycles matched a 41,000 year cycle in obliquity, or switching to 100,000 year cycle match eccentricity. So that means you have the ice age at 20,000 years, and then 20,000 years later, it'll be interglacial, and back to a glacial, interglacial in these cycles. And that results in what we see on the coastal plain, scarp and terrace topography. When we're in a glacial, sea level is low, interglacial sea level is high. And we have these high sea levels, you have what's called marine transgression. The ocean goes over land and deposits the sediment. Here we have the Bacon's Castle, which we're going to talk about today. TBC is here at the top. I have Richmond here. This is west. This is east, going to the Chesapeake Bay. And you can see each successive marine high stand, it creates a stair-step topography. Each time eroding and depositing a sediment, each glacial high stand. So Bacon's Castle Formation was formed 1.6 to 1.8 million years ago. So it was a marine transgressive unit, and this was subdivided into two members, the Varina Grove and the Brownsville. The Varina Grove is the fluvial gravel and sands, but we don't see that here at Stratford. You go further south to the James River, I believe. The one that's present here is the Brownsville. That's a fluvial to tidal flat deltaic complex. Estuary deposits, shallow marine deposits, coastal environment. Depositional environments at that time would include similar to what kind of we see today: estuarine, forested swamps and bogs. And these bogs were rich in iron groundwater. So that helped create these bog iron deposits. We also have tidal mud flats and sand flats. And these create your fine, coarse sandstones and mudstones. Brownsville was typically it's gray to yellowish orange and reddish brown, thinly bedded to laminated, and often contains varying amounts of sand and silt. Like I said, here you can find all different colors. This is more typical of the limonite. You also find a very dark, almost red and blacks and grays. You see here in Florida, North America, it was mined for building material. When we were having lunch this morning, the fireplace, I believe, had ironstone in it. I believe the slave quarters, and other buildings here Stratford Hall are made from mined bog iron. And of course, this is also used for source of iron during colonial times for products. The biggest capsule formation has been well mapped, but it's understudied due to its coarse, gravelly nature and highly oxidizing environment. We don't see any body fossils, no calcareous fossils for sure. But the more we look, the more we find. So that's where Rob and I come in. I recover the fossilized pollen grains, and he does the animal footprints, and both found from bone and wood, which there is supposed to be. So, all right, part one. So, part two. What is palynology and how is it used? Palynology is the study of pollen and spores from plants and ferns and certain microscopic plankton, so like algae, bacteria, fungi. Flora is the pollen spores of a region or site as a whole. Of course, paleo means old, fossil. But how is palynology useful? Palynology, pollen can be a powerful tool for environmental reconstructing. It's a great proxy. And what does that mean? It means you can use it to infer a lot of different things. If you know what was growing, or I should start again, certain plants, certain trees, they require certain amounts of light, water. They like to grow in certain environments. So if you know what was growing, then you can kind of deduce what kind of environment they were growing in. So you can tell how warm it is, how much water the area is receiving. You can also use it as a proxy for land use change. You can see when there's been agricultural in an area, like Virginia, in colonial times, you can use like tobacco or corn as a good indicator of farm use. You can also tell when an area has been deforested. Usually find lots of charcoal in the sediment as well. But you can use pollen to kind of figure out all of these different things. There are applications in the field of archaeology, food source and diet, biology and ecology for plant identification, and ecological restoration projects. Geology and paleoecology, obviously, for biostratigraphic markers. And I'll give an example of one later. And also forensics. Interesting story I have about forensics. So it was about 10 years ago or so, we were approached by the FBI. There was a gruesome murder case where a guy had kidnapped his wife, 2 children. Unfortunately, he killed them. He hid the bodies. He was arrested. The authorities found a shovel in his trunk. So they gave us soil samples from the shovel. And we were able to, show what plants were growing in this mud, what was available. And they were able to narrow the area down into this region of Ohio. And they were actually able to find where he buried them. So this is one of the applications that we can use that is very interesting. So for field work, we collect different kind of cores. We collect, here's an example of a fiber core. This is an aluminum tube, and these are handles here, and we push the tube down into the ground, but we have the help of a cement mixer, a little motor here, that would catch a wire to, and basically it vibrates the aluminum tube so that we can shove it down into the ground. And that's how we get one way to get a core. Here's a smaller section of core from a Russian peat core. And some friends of mine doing some work. They're taking a core from the Chesapeake Bay here on a makeshift 2 canoes and a platform here. You also collect samples from the cliffs. This is from Stratford. This is approximately 80 to 90 feet up. This is one I did not fall down from. John. All right, so once we take the core, we bring it back to the lab. Basically, we subject it to different acids, hydrochloric acid to get rid of any calcareous material, hydrofluoric acid to get rid of siliceous material. And basically, we whittle it down so we can get it down on a microscope slide. And then I take it and I count pollen. And this section here, I want to show you a representation of common pollen that you might be familiar with, or the trees you're familiar with. So this is pine, or pinus. So it's tropical to boreal. It's pretty wide range kind of species. This is the body, and here are two bladders. These are air bladders. They allow the pollen to go a great distance. So pine and firs and other things in the pine family can travel very far because of these air bladders. This is oak. There are many different varieties of oak. This is a general oak. And these are also widespread tropical to temperate. This is hickory or careo. Has 3 pores around the outside. Habitat is subtropical to temperate. See those right here today. Here's walnut, very similar, it's related, but it has more pores, not just around the outside, around the whole body. These are also subtropical temperate. Ragweed, this is an important one for palynologists. This one is indicative of disturbed areas. That's useful for land use change. You know, when you see a lot of ambrosia or a spike of ambrosia, that most likely was some kind of land clearance. Ambrosia are one of the first plants to move into a disturbed area, be cutting down forest fires and what have you. That'll be one of the first things you'll see. So you'll see a spike of ambrosia. And this is one of the ones that most people are allergic to. Holly or ilex. This is tropical temperate. This is my least favorite tree. All right, this is corn. This is one that's great for agricultural. This is corn or maize. This one it's kind of crumpled, but these are very large and with one single pore to distinguish them. You go. It has choroid-like features right here. Latin liquidambar. This one is important. This is a cypress, like bald cypress. We still have those in Virginia and Maryland in certain parts. But they're very indicative of a subtropical temperate environment. This is birch. This is a pretty one. It's trichorate. As we can see, it looks like two little hands or fingers coming together. This is tubulose. Subtropical type of great honey. This is chestnut. We don't see very many chestnuts around here anymore, though, do we? The chestnut blight was approximately 1905, 1906. You see occasional chestnuts around here. I think once they reach maturity that they can reproduce fruit, they reproduce for like 1 or 2 years, and then they end up dying. So they don't live very long. All right, this is wingnut. This is also an important one for palynologists. This one is not native to North America. It's originally from Asia, China, I believe. It existed in North America during the Pliocene, but once the Pleistocene started, it disappeared. So if you're looking at a sample and you see terracaria, most likely you're in the Pliocene for later. So it's a very good marker for good work here. And once I count the pollen, I made a graph, looks something like this. I know these are kind of hard to read, but this is pine here, oak, alder, and down the line. Basically, what I wanted to see is that you can see changes over time. This is the core depth. And if you can find things in the core, charcoal, wood fragments, bone, other things that you can date, like carbon 14 dating, you match dates to certain levels, and then you can see how the landscape has changed over time. So you can see here, this was a project I did in southern Maryland near Baltimore on a stream restoration project. And we wanted to see how that environment changed during colonial times. So this is what I call the agricultural horizon here. So that's when things first started moving around. You see here, this is a stream environment, so that they came in and they cut down all the pillars. They started putting in farms, big slaughterhouses and stuff. And you see, I talked about before about the ambrosia, the ragweed. You see a big spike here, so you know that there's some kind of change there. So that's a big change, and then how they change together. Okay, so about a year ago or so, I found this bed fossil bed. We were able to identify the bone was belonging to glyptodons. And so I took a sample from underneath the bone to try to see what kind of environment it was laid down. So we were able to identify the animal from one bone. The ankle bones were here. It belongs to the glyptodon. You can see the little ankle here. And I believe that's a type of armadillo. Armadillo-like. And so it was great that we were able to tie exactly what that was. So the sample I took, what did I get? I actually found a lot of pollen on 26 different species. Majority by far were dominated by trees. Oak was 72%, followed by pine and hickory. Now, one thing I have to say about oak and pine, not all trees produce the same amount of pollen. Some trees produce more, some trees produce less. Some are pollinated by the wind, some are pollinated by insects. So oak and pine, for instance, are both wind pollinated. So they produce and shed a lot more pollen. So this number, yes, it's exaggerated, but I imagine oak still made up probably close to 40, about 50% of the trees during this time. And like about pine has the bladder. So pine can travel a further distance. So pine is probably more representative of more of a regional environment versus some of these other trees were more of a local environment. A lot of trees occur in less than 1%, including cypress. And one thing I want to point out is fir. There are very few boreal elements at all. Fir, I think, was the only one. And those travel long distance as well. So that helped me conclude that the pollen assemblage reflects a broadly temperate subtropical environment with very few boreal elements, indicative of a warm interglacial period. And the flora is consistent with forested wetland habitats, tolerant of frequent flooding. And the climate was as warm, if not warmer, than today. That's the end of part 2. Now,
anyway, trying to speak to a good summary of the material we get out of this extensive formation. So now I'm going to go on to the animals. And most of those, it turns out the ironstones in the Bacon's Castle preserve a number of footprints. And these are all kinds of creatures. So anyway, we're going to go through briefly some of the ones that have been found and what this tells us about what life was like back then. Now, in a lot of Ice Age Pleistocene deposits, the animals that we know about are known for their skeletal names. This is a mammoth, probably, from the Los Angeles La Brea tar site, and which is a very famous Pleistocene site. And the animals sunk down in the tar and the bones were preserved. So you get whole skeletons and things, and that's all wonderful. Around here, because the Bacon's Castle is sitting at the top of the cliff, the groundwater has leaked through. And in a few exceptional cases, like the one Barney showed you, the water leaches the bone material out, it just crumples and goes away. So there may have been lots of bones in there at one time, but they're all gone now. The footprints remain. And the footprints come in two basic types, which is, if you think about it, that's all it would be. One, which is it's the one to the left side. Those are actual footprints in what used to be sediment. It's been turned to iron now. But you can see that they're toes and they squash down into the mud. On the right side, it looks a little strange. And that's because that's what actually filled in another level of what was the stuff to the left side. In other words, if you had material to the left and layer on top, if you lifted it up and flipped it over, you get something akin to what you see on the right side. And what's happening there is that you're seeing the actual toes that are sitting out into what used to be the holes. And then you see these two lines of rock. Those are places where there were mud cracks, and the ground opened up and then filled back in with muddy material, which became turned to the ironstone. So that tells you right there that it was wet but it dried out. So all kinds of environmental information comes into this, but those are the two basic types of fossil tracks that you get, the actual impressions and then the fillings of it. So it's a little interesting. It's kind of like when you're going along and pick up stuff, you got to kind of flip your eyes back and forth, am I looking at the actual thing or am I looking at the filling of it? And that takes a little while to get used to. But once you do, it's not too hard to deal with it. Okay. So if you go out and you look at the cliffs from a distance, you basically see that the lower 2/3, 3/4 of it is gray mudstone or greenish mudstone. And those are the Miocene beds. They're marine, which is why they have the gray to green color. The bacteria that was in the bottom sediments oxidized the iron that was in the rocks and caused it to be reduced to the minerals that are the bluish grayish color. But once you get above where that line is, you see, there you go, that line there. That material right in there, that's where the ironstone comes from. So that the bottom of it is the Miocene material. And starting there with the ironstone is the Bacon's Castle. Then running up from it, mostly yellowish oranges, is more of the Bacon's Castle material, but not the ironstone. The more fluvial sands and things of that sort. So that's where this material is coming from. It's way up the cliffs. There are a few places where you can get up there and take some look at it, but for the most part, what happens is when the cliffs start to erode, the stuff slopes down and ends up getting churned into pieces on the beach. And so what we normally do or have people do is to look along the beach for blocks of this ironstone from up there. And it's down the beach now, but that's where it originally came from. So once we discovered the fossils, which I guess was, I don't even remember now, it was about 8 or 10 years ago. How long ago was it? 8 or 10 years? 5 or 6 years. 5 or 6, okay. That was when we first started to find these things. And a whole bunch came in right at first, and I sorted through them with books on fossil mammal footprints, really birds and others, and put together a paper which was in Fossil Record 6, the New Mexico Museum of Natural History and Science Bulletin. You can go online and find it there or order copies if you like. But anyway, there was this article that was by me on Early Pleistocene, Early Irvingtonian footprint fauna from the Bacon's Castle Formation, Westmoreland County, Virginia. And since then, we've had more material show up. I've had another paper out in the same series farther along, 8 or 9, I think, for the record. But at any rate, it's continued to come in, and over time, just by the nature of the way stuff comes in, at first, everything you find is something new, and then more and more is starting to be repeats, maybe better repeats than what you found before. Then eventually gets to where really new stuff is fairly rare. That's kind of where we've got to now. But there's more stuff, I'm sure, to be found. We're not at the end of the line. At any rate, up until recently, I added together what was published plus what's in the bins down here in Stratford. And as of a fairly recent time, a few years ago, there were 37 kinds of animals that we can say used to live here in the early Pleistocene. And 3 of these are little amphibians, 5 are reptiles, 7 birds. Birds are a little hard because unless you get a really good footprint, they tend to all look the same. But once you get a really good set of prints, you can start to, and of course the size is a big deal there, but you can start to go apart. And finally, of course, what we have is a lot of land mammals, 22 kinds. And that's interesting because, you know, in Stratford, the gray beds, that's all marine stuff. So you're mostly seeing dolphins and whales. And every now and then a land animal will show up in there, and their bones, of course. But here, everything you see is land animals. So we know that this was not being deposited in marine environment. Okay, I'll run through some of these with you. The ones that are in the older paper are black and white. I took copies of that. So if you're seeing a picture that has color pictures, these are ones that weren't published in that original paper. The ones that are gray are taken from that paper from the fossil record. But anyway, I said there were 3 kinds. Actually, 3 kinds of amphibians. But at any rate, no. At any rate, there's a salamander. That's a manus print, and it's right there. And you can see there are little stubby toes on the end. The most distinctive about them is that there are no claw marks. If you're dealing with lizards or something like that, they'll have claws on the end, but salamanders just have soft toes. So that is that way. And of course, with the number of claws and size, we were able to identify it. And there are also frogs, another kind of amphibian. This is foot of a bullfrog. They're very big. That's one of the ways you can tell from the other kinds of frogs is the big frog footprints. And also, we have little brown lizard that's white. This one, young fellow found it. And there's 1, 2, 3, 4 prints. That's the 4th toe. That's the longer. This is the back foot. And again, you can see there's a millimeter scale on a ruler. So very tiny little thing. Some of these you have to look really close together, but they're there. Other things that are a bit bigger are painted turtle toad. Now here, besides these being grained from the older literature, on the left side we have just the prints as you see them. On the right side, I put in coloring to outline the prints, so you can go back and forth and convince yourself that what I'm showing you on the left side is there. And we have painted turtle, which is here, and toad. That's the toes of the back foot and front foot there. And then this is a painted turtle front track. And snapping turtle, the toes wider, and this is more the front, but it's moving along, it wasn't just standing. So we have a variety of these animals. And one of the neater ones is that we get some tracks that are really big. I mean, that's 5 centimeters, that's 2 inches. And you can see these are good sized tracks. This is a big tortoise. Not like anything you see today, but things more like you get out in the desert Southwest. And it's a thing called Hesperotestudo. Some of these things, the shells get like 4 or 5 feet long. They're really big. And they hung around for a long time through the Ice Age. So that's kind of what they look like. Now, among the last of the reptiles, we have alligator prints. This is, I think we will pause that. We have the back foot of an alligator. Now, you know, they kind of are sprawly, but when they're in very shallow water and something along it, put out and kind of sweep back as it moves forward. And that gives it this S-shaped pattern because the toes curl and it's moving along. This is the front foot, the toe marks and the hand marks. So those are alligator tracks, and they indicate that there are quite a number of alligators in this farm. And as far as birds, here we have killdeer tracks. Up here, tern, American sparrow, and one of the more interesting ones we found are turkey tracks. So turkeys have been here at least all the way back to the beginning of the Pleistocene. So, they're part of the story for a long time. Now, since the original article was published, we've got 3 new kinds of birds that have shown up. That includes the American crow, which is another one that seems to have been around here forever. Red-shouldered hawks and American pipits have shown up. So and the birds are ones that the tracks are hard on. You can tell a bird, but beyond that, oftentimes you can't tell much. But little by little, as the tracks come in, show up. So we'll be getting, I'm sure, more kinds of birds added to fauna. But we've got a fair number already. Now, among the mammals, we've got, say up here, Xenarthrans. That's a word, really means strange. Xenos is strange. And it includes things like armadillos, which are at the bottom, and also ground sloths and other things that are South American animals that have moved north. So Dazicus is the armadillo proper. The whole Xena is a bigger thing. It's somewhat similar to an armadillo. It's armored with more round. And they've shown up, and the tracks are pretty distinct. This is one. Well, what we're looking at here, that is a rear foot and a rear foot. So you've got 2 rear feet side by side. As with armadillos, they tend to stand up on the back feet and get up and look around. So that's what you're seeing there. Now, over here, we have megalonyx. That's a big ground sloth. We have the tree sloths today, but the ground sloths go around here in the Pleistocene. And they have very distinctive and unusual feet. And the other parts of them, never got a whole one. They're pretty good size. But they're here. And the other one that's shown up, and this is a baby. And this is a moose or a mastodon. So this is a prehistoric creature, and it's elephant-like. But these are not big enough to be the adults. And then we get lots of rodents and carnivores. Muskrats, there's a rear front foot and rear foot. And then here we have a capybara. And those are still around in Central America, South America, but they're not here anymore. And this is also capybara. That's a front foot and rear foot. And then we have eastern wood rats. They're small. They left a lot of prints. They apparently were pretty abundant around here. And lesser prints of things, river otter, coyote, that's a carnivore, of course, and something called our Brewster's wolf, which is related to modern wolves, but it's enough different we can tell it's not the same. So anyway, others, we've got black bear prints, bobcat prints. This is one of them. There are two of those, you think like cows or bison. They have the two big hooves side by side, and this is only one. It broke out separately, but that's part of a shrub ox, which is common here in the Ice Age. And then we have a block with a bunch of taper prints in it. And this one, there's so many taper prints, it probably it came through and stomped around in this case. These are more individual tracks. Papers are related to horses, except that instead of horses have one big hoof, we still have three some smaller hoofs. And the individual hoof prints sometimes will show up. And you see that's 2 centimeters and a little less than an inch. So these are fairly common. I've got one up here. You can look at. And then here's some other smaller traps. So they show up in bits and pieces. And then white-tailed deer showed up. They were around. And among other new prints, we've got a print here of Arctodus pristinus, which is a prehistoric kind of bear. They were good sized animal. Again, that's about 4 inches. You can see it's probably in the size range of a modern bear. And those are the prints, the paws, and that's the part of the foot that's in the butt here. We've got another one, the next slide. This is more just the prints, but you can see the prints marking out there. That's in one of the slave quarter ironstone frames and stone frame. And also in this one we found there, Manus, which is here, and the which is here, the striped skunk, the fetus. So that's another kind of animal shown in the Pleistocene fauna. In this case, we've got a quarter to give you the scale. So anyway, other carnivore prints are things like jaguars, which we've shown up here. That's a print that the animal kind of hit the ground and slid in, so that as it's moving forward, the leg is sliding back. So you get sort of a gouged out print here. And then there's a raccoon trap, which is in here, and a pongo skull. And these are common out west. They're not common around here anymore, but they used to be here in places. And then a few others. There's Picky's capybara, which was common in Pleistocene, going down. And one of the more interesting little animals that showed up are the prints of southern flying squirrel. So they're more south of here today. Anyway, all kinds of mammals, in other words, these have all shown up. And many of them are animals that are still in existence in this area. The coyote has been a while, got wiped out for a while, but it's making its way back. So it's returned. Black bears, of course, are fairly common. Southern flying squirrel, crow, rat, raccoon, richland, bobcat, river otter, striped skunk, muskrat, white-tailed deer. A lot of these are animals that are still in the area. There are others that are gone and extinct. And these include that our Brewster's wolf, the pompatheer, which is the armadillo relative, the shrub ox, jaguars, which aren't likely to come back. But they still exist in tropical America. Armadillos, they may well show back up. They're well up in North Carolina now, and they will probably work their way up here. But they're not here now. Ugly skunks, they're out west to come back. Capybaras are down in Florida and tapirs in Central America. So they're locally not around, but globally they still exist. The biggest animals we have in Florida are the American mastodon, which is here, megalonyx, which is the ground sloth, and then our totus, which is that really big bear-like creature. And those are big enough you wouldn't want to run into one. I don't think whether it was a good mood or not. Anyway, this is some of the ironstone. This is what the tracks show up in. And all kinds of things are in there. It's not all tracks by any means. These are things that iron is more concerned with. Ophiomorpha, which is a burrowing crustacean that digs out burrows from the mud. And when the burrows fill in, the ironstone will observe. And these are fairly common down there. You can find a lot of these. Also, if you look carefully, you'll see places where, like the ghost shrimp, leaves little scratch marks where they were in before the iron material got hardened up to a rock. And some of the things it shows up, not so common if it's there, is petrified wood, and also impressions of large logs. These things are in Wisconsin. Based on the absence of plains animals, the presence of alligators and tortoise traps, the lands around Stratford were forested by today, but back then, the climate was either much warmer or far more equable than today. By equable, I mean that if it was cooler, in the wintertime, there were a lot of clouds and it won't go freezing. But there weren't nearly as many freezing events. And it turns out, the pollen record that documents it as far as it also indicates the climate is warmer, somewhat warmer today. So pollen and the footprints so far are pretty complementary to each other. Suggests that we are in fact looking at the same story. Now, about the mammal tracks, the local environment was marshy. It had a lot of herbaceous vegetation. It may have been a major food source for the younger mammals. So they may have been out in this area looking for food. And the climate may have been exceptionally wet in spring when the animals were growing rapidly. And so a lot of the animal tracks we see seem to be younger animals. That's probably because a lot of the fossils were found in the springtime, and therefore there are a lot of juveniles. And the dense brush of vegetation probably also provided a good hiding place for the younger animals. But smaller and lighter animals probably had a better chance of escaping large predators on the soft marsh grounds and marsh areas. So a lot of these animals would tend to hang near the marshes so that if something came after them, they could get out into land where they could keep going along and bigger animals would sink in. Now, interestingly, for a long time, this was our story. But a few years ago, John Walker found footprints of mammals in Lake Pleistocene, which is down near the beach. And these tracks showed up for a while. They got swept out, but apparently they resurfaced. And if you want to go far enough down the beach to see them, some of these are now exposed again. So they are around. These are much younger. They're between 70 and 100,000 years ago. So they were right before the ones we said in pleasure. A lot of kinds of animal tracks are present. And one of these, if you see it here, these are alligators. This is a glyptodon. This is similar to the big armored thing that is on those. It was much bigger. And the other three tracks include a thing called llama, which is an animal made by llama-like animals that's here. In there, the reindeer-like tracks. And then these down around in here are tapirs. And the ones, some of these pictures, I think we can go down to each today and washed out some of these, which are probably elk, and then taper tracks down there again. So how about the others? So these are the animals that shown up in the Lake Pleistocene. And they're, in terms of the climate, they're similar to ones you saw before, but somewhat different set of animals. The llama's distinctive. And the elk is not quite like any of the early Pleistocene. The tapir, you can see the alligators with elephants. And Glyptotheria was close to the maybe a different genus, but it's close to the other animals, other Pleistocene. Again, very warm climate, not like that. So the discovery of two different track Pleistocene at Stratford suggests that there may be more track surfaces sitting around the places of beach and surf. And everybody should keep your eyes open for any signs of things here, because there may be other Pleistocene stories that are in existence and we don't know about yet to tell the story. Now, the other thing to keep in mind is that the fossils we find here at Stratford, as Brian was saying, these were cases when this surf line had come in. It was interglacial time, so the sea level came in, and these animals were buried at the beginning of the interglacial stages. But at times when the sea went out, there were ice age cold animals that were living in the area. And we so far haven't found any place where we can find these today. They might show up, but not so far. Where they do show up is a place in Western Virginia called Stratford Hall. There was apparently an earthquake that brought a landslide down and created a lake during the last glacial period. And a lot of bones have shown up there. And also off the East Coast today, back in the last ice age, that was land. Animals were out there wandering around and dying. People dredging stuff up off the seafloor occasionally bring these up. And a number of those have been brought into various fossil places. So we have to the west of Saltville and to the east under the coastline, we have ice age animals, true ice age animals. And almost certainly they were living here in between, but we don't have them yet. But it gives us some idea of what they are. And these are some of the animals that we can find. The record is biased towards bigger ones, but we seem to have good horse remains. Arctodus, that is what we see in the Pleistocene. It seems to have been pretty tolerant of cold and dry climates, both or cold and wet. Mastodon is fairly common. Butherian, that's muskox. Those were down in this area. Rangifer, which is reindeer, and Sabalses, which is extinct now, but that's related to moose. And besides the mastodon, we also get in the glacial stages the mastodon mammal. So related, but different set of animals. And so far we haven't seen this in Stratford, but who knows, maybe they'll show up yet. So anyway, that's the story as it stands now. But the nice thing about it is that new things keep showing up. So hopefully some new animals will show up, and maybe we'll find something today. We'll see. But that'll get you started. I have some John Bottom brought some fossil ironstone blocks with footprints in them. I'll drive up here and you can take a look at the body. Otherwise, you can go down the beach and you can find some of the ironstones. Here, I won't be that mobile. I'll be up to the picnic table, or at least down near the beach, and you can bring anything back to me and Brian. Stuff too. So we can take a look at whatever you find. So anyway, thank you.
Everybody starts moving around. I just want to make sure that those who joined us with Zoom, that there was no one who had any questions, or that if there was anybody in the audience that had a question that they would like to ask today. And also thank you both gentlemen for being here and for taking your time to share your knowledge with us. We really appreciate it. Let me check our chat. All right. Okay, so it doesn't appear that we have any questions on Zoom. If you do have a question, please put it into the chat and we will see if we can get an answer for you. Thank you everybody for joining us today. Anybody in the audience have a question?
Thank you. How far back can you go in time before pollen starts deteriorating, getting destroyed?
Good question. Depends on how it was deposited in the population, but First thing I pulled up from the early Miocene 21 years ago, it looks like it was positive. Yes. But we pulled on them a couple hundred million years old, all lignite coal samples. And then you look pretty beat up. But yeah, a couple hundred million years is not
Any attempts to make a true heritage tree from that pollen, or it's just using that pollen to create. I don't know how to ask it. Never mind. Any other questions in the audience? I'm sorry. Obviously, it wouldn't be in the Pleistocene, but have you ever come across human footprints?
of course, is what we know from the fossil record is what we find. Then there's what we don't find. And every now and then something shows up that you don't put blocks there. After a lot of arguments, people finally said, well, yeah, that did go there, it's just not up. So right now, the oldest human that we have remains of footprints out in the desert. And they have like, ground slope that's used. Those recently, they dated them, and then some people were concerned about whether there was groundwater forming and hydrocarbons that were recent, or older and getting older. So they put back and they dated it better with their samples. And also got the problem and they've now done it in 2 ways. Both of them saying so those are the oldest confirmed fossils in the world at this point. So one of the things about the Google is that another question. People are usually better at how to track these places. So they look at the fossils. And, it's not likely. It's not impossible, but like in this Pleistocene site, up to 1,000 years old, see what happens. Show up and get a thing to do. As far as we know, 1,000 years oldest. I think there are some places out there in North Egypt. It's a sand dune deposit higher up. But they do have some earth wood in there. That I think was about 60. And so, again, when we think about 18,000 years, unless there's 4,000 years to walk in the woods, it's out there, it's this way. And who knows if you could, but it's not necessarily. What's interesting about that is that for that first 6,000 years, or 4,000 years ago, these early humans, these fossil evidence, the 10,000 years ago, there's this other one that shows it as it comes down south. And they show on the western East fairly rapidly. And as they come through, most of the big mountains disappear. So, time seems like the first humans have been once they start close people, they just wiped out the mountains. And there's going on. We have some DNA from the experiments on it. It's older humans are very much beginning. They also confirm where we get the humans and mixing it with all this whether there's no connection, in which case people wipe it out a lot. It's a whole story that just can't be a story. But we don't have a story. So it's a lot of work. But as far as we know, this part of the world may be around 60,000 years old. And, you know, absence of evidence is not evidence of absence. And that's the story we know.
Thank you, everybody, for coming out today. That's going to end our lecture part. So thank you, everybody, for joining us on Zoom. I apologize again for those technical difficulties. We'll get this uploaded with both presentations available on our YouTube page shortly. Thank you.